Hey Caleb, this is Bhagilakshmi Varakantam. This is for assignment 3. Hey. So initially, I have written few helper functions, and few user descriptions to where which task is starting and ending at where. So this is start of deck of cards, and then the binary tree. So going to deck of cards, I have created a class for deck of cards, which I'll describe it in a bit, and writing the state of the cards to the um, console, and then search, which is described in the code, and then shuffling the deck, and then stating this, describing the state, and then the search, and then sorting the deck, and then the same. So here I have created the class deck of cards, which has a constructor to initially instantiate the cards of suits, and then 1 to 13 cards. The suits are diamonds, clubs, hearts, and spades, just like you said, and it uses the list of cards, which is a class card inherited from iComparable to compare them, which has a property suit and value, and the functions which describe the suit and the face value and equals function and the card name like ace of diamonds, something like that. And then compare to is used in sorting the cards, which is used for iComparable. And here, after constructor, I'm using the property is sorted and is shuffled to set the states. State of the cards, like to say sorted or shuffled. Initially they are sorted, so this is true, and by default is shuffled is false. And here the state of the cards is state of the deck is described by whether a sorted deck of like 52 cards, a sorted deck of shuffled deck of 52 cards. And sort, I'm using here a selection sort by setting is sorted to true, is shuffled to false. And then selection sort, I have been following the C# data structures and algorithms by Marcin Chamorro, just like the Python code you have been providing in the book. So here, the selection sort code is described here, which I would submit for the assignment. Coming back, search, I'm getting a card from user described user input card, and finding the location of the card and giving a proper string format of the card, saying ace of diamonds is at location 0 and so on. And shuffle, I'm using the random generator to pick an index randomly, and then pick the card at that random index and swap them. And describe card, getting the user input for suit and the value here with the proper valid numbers for suit 1 to 4 and value 1 to 13, as you can see. And then parsing the suit number to inner. So that is my deck of cards. Let's run in the application now. Okay, here, let's say I'm picking diamonds, ace of diamonds is at location 0. Now the card is shuffled. Ace, diamonds, ace at location 5. Now the cards are sorted using selection sort. Ace, diamonds, ace. So as you can see, it's at location 0. So that is for deck of cards. And coming back to the binary tree. Importing the random numbers using the static helper class, and then converting them to list of integers. And then I got this code from the C# data structures and algorithms, just like I said. Here the node is defined, implemented, and traverse orders, and then the tree which has a root and then the count. And here the to-do functions are described, the maximum depth of the tree and the leaf count, and search and insertion. So for each of the integers, I'm inserting them into the tree and forming them nodes of the tree, and getting the height of the tree and leaf nodes in a formatted way, which says the height of the tree is 14 and the number of leaves of the tree is 31. So that is the end of my assignment 3. Thanks, Caleb.